All right, everybody. Welcome to our June 2016 Hangout on Connectivity Troubleshooting. I'm Jim Pingle. This month, we'll be talking about different ways to troubleshoot connectivity. And this can work for, whether it's port forwards or VPNs or just local client connectivity, NAT, that sort of stuff. So general purpose stuff, it's really good to have in your tool bag. All right, first up, we'll be talking about some project news. As always, we'll go over just some basics on diagnostic tests in general, because they're things we're going to talk about throughout the Hangout. A little bit about testing methodology and how you'll want to approach some problems. Common causes of what appear to be disappearing packets. Just a little bit about subnets and routes that you'll need to understand. And then we'll talk about certain items to check over on like WAN configuration, LAN configuration, firewall rules, outbound NAT, firewall connectivity, and looking for DNS issues. And lastly, looking on the client configuration to see if there's a problem there. There are, some other causes and things we'll get into, at the end, and then we'll have hopefully have some time for Q&A depending on how fast we get through everything else. All right, first up is our project news. Our pfSense 2.3.1 update 5 is out. You might also see that printed as 2.3.1 release P5 or 2.3.1_5. Either way, it's update 5. It's a maintenance release with security and stability fixes since our update 1. We did have updates 2 through 4 internally, just for our own use for testing and internal things. So those weren't public. If you didn't see a 2 or 3 or 4, you didn't miss anything. The only public ones so far have been 1 and 5. We did new for our XG2758. We have a redesigned case that can now accept add-on boards. So if you go onto the store and look up the XG2758, you'll notice there's now an expansion board option. The only option we have at the moment is a 4-port 1 gig card. I believe it's Intel interfaces. It's very subtle on the front of the case. I'm not sure you can see it in this picture. It may not do it justice, but there's a knockout there on the top for where that card where that card goes. We had BSDCan earlier this month, which is a BSD convention that's up in Canada. One of our guys, Louise, was talking about NetMap-FWD or NetMap Forward. It's a user land router application that uses NetMap for FreeBSD. It's easy to use, very, very fast, aimed at 10 gig networks. He's just got IPv6 working in it now, but he hasn't got all that checked into GitHub. That is being developed on our XG2758 platform, which a lot of our things are. They will work on a few other of our SG devices, depending on the hardware. But when all that comes out, we'll talk about that a bit more. If you're interested in looking at the code or looking at a little bit more information about NetMap Forward, you can look at follow that link to the BSDCan summary. It's also got a video of his talk that he gave in Canada. Our online training schedule's up for the rest of the year. There are spots open in all the announced times, so if there's anyone you're looking at specifically, you might want to go ahead and sign up. September's starting to fill up, so you might, if you think you might want to do it in September, you might want to jump on that. You can go to netgate.com/training, and our schedule and everything else is up there. Okay, well, just a little bit of background basics that you might need to know. You might be familiar with these, you might not. Or even if you are familiar with them, you may not know 100% about them. Just a few little quick diagnostic tests you can use to do a lot of this evaluation. One of the most basic tests is ping, which is a connectivity test, uses an ICMP echo request. It sends out a request and the other side sees that request, it will send back a reply. So it's just a basic test to say, hey, can I reach you and can I get back? You can do that from the pfSense GUI under the diagnostics menu and then ping. And there's a ping utility for almost every operating system. There are variants for like ping is for IPv4, ping 6 is for IPv6. Some operating systems will use IPv4 and IPv6 both with the same ping. So you just need to check your operating system documentation or just try the commands and see what works. Now that does use the ICMP protocol, so it's not a perfect test. A lot of things might either specifically block ICMP or they might pass ICMP when something else like TCP would break. So it might give you a good network level reliability indication if it's good, but a negative doesn't always mean there's a problem, unfortunately. Another diagnostic tool is traceroute. It will trace the path to a destination, and you can do that under Diagnostics and Traceroute on the pfSense GUI. What that does is it sends out a bunch of packets, each with like a time to live of, a hop or two. And then when it gets that back, it'll increase that on and on and on. And as it gets replies back, it will get replies back from the intermediate hops along a path. So it's really good for testing to see, how far you get or what the hops are between you and your destination. When we're talking about things like diagnostic troubleshooting, it can help you see like, okay, I'm getting to my firewall, I'm getting to a hop past there, I'm getting to, all the way out to the internet, or I'm getting 3 or 4 hops out and it stops, something along those lines. Also, not a perfect test. There are 2 variations of traceroute. Some use ICMP and some use UDP, and some you can switch. So you may have to try one, try the other, try both, see if you get any better results. It's also not perfect because some intermediate hops will block it, or some endpoints will block it. There are also cases where you won't see a hop in traceroute, like with IPsec, or when you have policy routing. Like when you have policy routing, pfSense will hand that packet off upstream. It doesn't decrease the TTL. So when you ping across, or when you do a traceroute out of policy routed WAN, the firewall won't show up as a hop. You'll see your hop and then out to the internet. So again, it's a good test in general, but there are some specific cases where it may not show you exactly what you want to see. Another handy tool is packet captures to see what's on the wire. That's under Diagnostics and Packet Capture, or you can do it using TCP dump in the command line shell, or there are utilities for GUIs for like Windows and Mac and Linux with like Wireshark that will let you run a capture directly there. And there are even ways where you can run a capture using Wireshark locally, using the firewall remotely. We have some info on the wiki and in the book for that. Packet captures are great because they let you see what's on the wire, what leaves, what's coming in, the MAC addresses as they leave and go, so you can confirm, layer 2 and just very good low-level networking stuff if you know what to look for. We actually have a hangout up on packet captures from a couple of years back. It's in the Hangout archive if you want to go back and watch that for a lot more info there. I'm not going to get into the nitty-gritty details of that, just a couple of places where it might be useful. I might show you a little bit in a demo if I can squeeze it in. Another good test is using Netcat. It's an easy way to test a TCP port handshake, like a 3-way handshake. You can do that under Diagnostics and Test port, or you can go from a shell, like on the firewall with NC. A lot of operating systems, like Linux-based operating systems, they'll have Netcat built in, or it's very easy to install. Windows, and you can do it in Cygwin. There might be another equivalent in Windows that I can't think of, but it's just a really good quick test that you can use to just to do a whole TCP handshake to make sure that you can make a good solid TCP connection. Downside to that, there has to be something listening on the other end specifically. So you need to hit a web server like on port 80 or 443, maybe SSH port on something, and whatever you're trying to hit has to allow that, obviously. So again, a positive is usually almost always going to be a good indication that you've got a good connectivity. Negative may not always be a negative because the far side may not be listening there. And using that command I've got there with VZ, what that does is it gives you a verbose and just a simple test. It doesn't try to connect and keep that connection open. It just tests the 3-way handshake. It says, okay, I sent you a SYN, you sent me a SYN-ACK, and I sent you an ACK back. And so it's a good way to know that you've got a good 2-way TCP communication happening. So a little bit about testing methodology, where to start and what to look at. So you'd always want to test from one side to the other, starting as close to the source of the traffic as you can, and then at each hop you can along the way. So what I mean by that is you don't want to go from one side completely to the other and then kind of guess where in between you might want to start. You want to do it methodically, just to make sure that you're seeing every step of the way to make sure it's getting as far as you can. Now, you could start in the complete opposite direction and then go to where you start seeing something, but it's usually best to confirm things look good on the way in as much as you can. So what that means is if you're looking at inbound traffic, like a port forward or an incoming VPN connection or a routed connection coming in, you want to start as far away as you can, like even on the remote system if you've got access to it, or the remote firewall. And then from there, that comes through your internet connection. You test it on the firewall WAN or your VPN interface or maybe MPLS, whatever, your DMZ. And then you look for where it's leaving the firewall out to the LAN, and then you actually look at the client device, the client's LAN connection. if you can. And that's where something like Wireshark would come in handy. You can see if what is coming in is actually hitting your local system. Now for outbound traffic, it's the exact opposite way. You check the client first, make sure the traffic is leaving the client, check the LAN, make sure the traffic's entering the LAN, check the WAN or your VPN, make sure that the traffic is leaving the firewall, and then see if the remote system is receiving that traffic. Now, also when I talk about VPNs here too, another good thing to test is if it is a VPN, you also have to consider your WANs as well. So the VPN traffic, it may leave the VPN, but then that VPN traffic has another hop where it actually leaves your WAN and then arrives at the WAN on the other side and then would arrive in the VPN and then your internal network. Where that becomes really important to consider is with IPsec, because we have seen on a number of occasions where an ISP or an intermediate device will block the ESP packets that encapsulate the IPsec payload. So somebody sends you some traffic across IPsec, you might see the ESP packet leave your WAN, but that packet never arrives on the other side. So at that point, it becomes really important because you need to get on the phone with one or the other of your ISPs and make sure that they're not blocking that traffic. Or if they are and there's no way around it, you may have to seek a different VPN solution. So that's something you need to consider as well, is every possible leg of the hop includes the encapsulated VPN traffic. So, and obviously if you have access to hops in between, check those as well. If you land, on a fiber router or something before and you can do any kind of diagnostic test there, that's a good place to start too. Or if you happen to have somebody in the know at your ISP, you could maybe involve them and see if your traffic's getting through. In most cases, you don't need to worry about that, but every once in a while, it's handy to have somebody on the line if you can. Another good thing to do is check your state table to see if the traffic is passing. You can also check your firewall logs. Sometimes, you may see a firewall log entry if your logs are set to log the activity that happened to the packet. Various configurations can prevent that from happening. You might have your default logging turned off for the default block rule. You might have it might be hitting a block rule without logs set, or it could be passing, or there could be some other things to look out for there. But seeing something in the log is a good indication that it did get blocked, but just because it's not in the log doesn't mean it wasn't blocked, because it could be hitting some other rule that doesn't have logging. Looking in the state table is a good way to tell if something passed, because if something did pass, there will be a state for it unless your firewall is disabled. So if you check your state table, you see a state for it, you're going to see at least 2 states for every normal connection. You'll see a connection for the state coming in the LAN from the client in the LAN coming to the firewall, and you'll see another state leaving the WAN. And the states that involve NAT, like a port forward on the way in or outbound NAT on the way out, the WAN side state or the exit interface or entering interface, the interface where the NAT happens is going to show 3 IP addresses in the state. It'll show the internal address and port, the external address and port, and the other end of the connection, whether it's the source of the traffic for inbound things or the destination of the traffic for outbound things. And so as you go down the line, you can, if all that looks okay, you can run a packet capture again to make sure everything looks all right. Like when your traffic is leaving your LAN going toward a local LAN client, if you run a packet capture there, you can look at the source and the destination MAC addresses, make sure it's going to the right system. If there's an IP conflict of some sort, you might see a packet go to a MAC address that isn't actually on your client. Or you might see a packet from the client leave going to an IP address or your gateway IP address, but that MAC address doesn't actually line up with your firewall. And that's a great indication you've got an IP conflict or some other network conflict happening. So I talked a little bit about disappearing packets earlier. There's a few ways packets can disappear. So what I mean by disappearing packets is a packet that would enter your LAN, but then you're capturing on your WAN. It comes in the LAN, you don't see it leave the WAN. Or it comes in the WAN, but it never leaves your LAN. Or you see it come in WAN, out LAN, back in LAN, but never exits back the WAN. Things like that, where it just seems to die, where you don't see any evidence of it ever leaving the firewall. Now, you could be just capturing on the wrong interface, like maybe you expected it to leave by the VPN, but it left by the WAN, which is common in a case where you might be trying to like port forward or route some traffic for like maybe across OpenVPN, but maybe the return routing isn't right, so it might come in OpenVPN, out LAN, back in LAN, and out the WAN. So that's something where maybe you're just not capturing on the right interface, and so you can try other interfaces as you test and see where the traffic is going. You could have policy routing could be sending it out a different interface, a static route could be, or a lack of a route could be causing it to go out the WAN or default gateway route instead of back where you wanted it to go. Another thing that can cause packets to disappear is an IPsec SPD matching can interfere with OpenVPN and other traffic. So say you had IPsec and you have OpenVPN and they were both trying to go to the same source and same destination. Well, if you disable or turn off IPsec, then it should be okay. But if that IPsec tunnel is there defined but not configured, like say maybe the remote end tore down their tunnel, but your end never disabled it. Now, when you try to replace that with OpenVPN, the packet would come in the firewall, but it would get dropped because it matches the IPsec security policy, but that IPsec tunnel is not up, so it would get dropped. Same with the other direction, as it tries to leave, IPsec would say, well, hey, that packet matches what should have come from IPsec, but it didn't come from IPsec. That must be dangerous. I'll drop it. So that's a good thing to check for. If you see traffic disappearing like that, check and make sure if you should have IPsec enabled, that it is there, and if you shouldn't, that it's gone. Another way you'll see disappearing traffic like that is if you have a missing route, like a default or a link route. So basically, if the firewall doesn't know where to send that packet, it will get dropped. You might see that if you have no default gateway set on your firewall, if you look and there's no default gateway at all, then if a packet tries to come in from LAN, it will say, well, I don't know what to do with that, and it will just go nowhere. It won't leave. Same thing will happen sometimes with other cases where you might have a missing link route, or you might have, like I said, no default route, or some other routing case where basically it doesn't know where to send that traffic, so it just dies. It won't go anywhere. Another way you'll get traffic that looks like it disappears is if you have a captive portal on your LAN. So if you've got, say, a server on your LAN and LAN has captive portal active, if somebody tries to hit a port forward or comes across a VPN, tries to leave going to that server, and that server hasn't logged into the portal, that traffic is going to be blocked by captive portal and prevented from coming through. That way, because it thinks it should, because there's no bypass in there for the portal. So what you can do to get around that is you can add either a MAC bypass or an IP bypass, and the IP bypass you can set to like a 2 value so that traffic going to that server will be passed and the return traffic should go. But normally you just, in a case like that, you either not put that server behind a portal, or you just set up a bypass so it can go both ways. Another reason that we hit every once in a while, it's pretty rare, but you might see something get dropped by PF silently if there is a PF state mismatch or some other PF issue. Like if we saw this happen the other day where there were 2 different port forwards on 2 different external ports trying to go to the same internal connection port, and the remote was trying to send using the same source port to both of those port forwards, and only one would work because PF had known about the association from the original source and original destination, but even though the intermediate NAT bit was different, it wouldn't make a new state for it, and the packet just disappeared. So, so there are some edge cases. They're very rare, but they are things to look out for. I'll talk a little bit about subnets and routes. Just because, so a lot of the things I'm going to talk about in the next slides are related to IP connectivity, and there are a lot of things here that are very easy to get wrong. So just a few things to consider here. An IP address and the subnet mask together define what hosts are local in that subnet, and then the subnet mask is defined mathematically. So you might be familiar with 192.168.1.0/24 or 255.255.255.0, which basically means that anything that has a 192.168.1.whatever IP address is going to be local to one another. Now that subnet is figured out mathematically, like the example I've got here on the screen. If you're looking at 192.168.1.0/24 and you want to make that subnet bigger, you might think, well, I'll just give it a bigger subnet mask, so you got 192.168.0/23. Now, the most common mistake we see is somebody thinking that 1.0/23 is .1 and .2 because they've told it to start at 1. However, that subnet mask is done, bitwise math, and it really is .0 and .1, not .1 and .2. So it doesn't matter what address you try to feed a subnet as its starting point, anything inside that subnet is really going to be the same subnet. So it's really from .0.0 to .1.255, no matter what IP address you say is your starting point. So it's something to be careful of. We see that a lot, especially when people try to renumber their networks or expand them. It's a very, very common mistake. So you always want to find a subnet calculator out there. There's a million of them on the web, or there's also local apps and whatever. So just find a subnet calculator, feed it your addresses, and look at what it says your host range is going to be, just to confirm what what you're thinking matches up with what the computer thinks it's going to be, or the computer knows it's going to be actually. Okay, so hosts inside of a subnet are going to find each other using ARP. So they're not going to try to use a gateway. They're going to send out a little message that says, okay, who's got this IP address? And then that IP address is going to respond, okay, I'm over here. They're going to find each other, they'll talk using the MAC addresses on the switch at layer 2. So that's all local. There's no routing involved there. And that works just fine as long as both hosts have the right subnet mask and they've got the right IP addresses and that there's no conflicts, things like that. So, on their interfaces that connect to that subnet, they'll have a link route that says, okay, I have this IP address and the rest of this subnet is reached on this interface here. And so that traffic, anything for that subnet will try to use that interface, and then the ARP goes on that interface, and then it finds each other and off they go. Now, what that means on pfSense, another very common mistake we see is somebody opens up a new pfSense box out, just out of the packaging, or a fresh installation, and their existing network is 192.168.1.1, and they plug the WAN of their new box into that 192.168.1.1. Well, our default LAN is 192.168.1.1, so when you do that, you now have a system that thinks 192.168.1.1 is, or .1.0/24 is on both the WAN and the LAN. And so because you can only have a link route to one subnet on one interface like that, your traffic is not going to flow. Either from the LAN side, you won't be able to reach the firewall, or if you can reach the firewall, it can't get out because its link route is only going to have one network or the other. It's not going to have both. So what you'd have to do in that case is boot it up without the WAN connected, get in there, change the subnet for the LAN to something else that doesn't conflict, and then connect it. So you just need to be sure that if you're trying to do something like that, you can't have the same subnet defined on two interfaces, even two different IP addresses, because in that case it causes a conflict. If you absolutely have to have two interfaces in the same subnet, what you do is you set up a bridge, and then you still only have one interface on that bridge with an IP address, preferably the bridge itself. But in that case, it's not violating that rule. You may have two interfaces on the same network, but they are part of a common bridge, and there's still just one interface link route, and that is a part of the bridge, and it sorts itself out. So the problem there is the conflicting link routes and trying to suss out where the traffic is supposed to go. All right, so that's all fine and dandy for traffic inside your local network. For things outside of that, there are two different things to consider. You have static routes on the host, which are less and less common these days, and you have your default gateway. Now you might have a system hanging around, maybe like a printer or a DVR, some sort of specialized box that maybe didn't get fully configured right. Maybe somebody forgot to put a default gateway on it, or maybe there's a statically configured host somewhere that only ever had a local IP address and no gateway. Those kinds of things will cause it to not be able to talk outside of its subnet. Now, static route on a client, that can cause you some grief. Later on, I'll talk about that a little bit later, but basically, it needs to be pointing to the right place, to a gateway it can reach, and it needs to be a valid route. When you're using static routes like that, you can do static routes on the firewall, and they can direct traffic out different interfaces as well, say like a VPN or out a second WAN, or across an MPLS circuit, or to some other router on your LAN even. when you're doing that, typically both parties will need a route. Side A needs to know how to route to side B, and then side B needs to know how to route back to side A. There are some ways around that occasionally with NAT or asymmetric routing scenarios if the router is actually on your LAN. But in most cases, you're going to have to worry about some sort of routing in both directions. So a little bit more about subnets and routes. If that subnet mask is incorrect, you can get a couple of problems. I touched on this just briefly a moment ago. If the mask is too small on your host, you may not be able to reach your gateway. There are going to be a chunk of what should be your subnet that you can't talk to, and you might be using the wrong broadcast address. Long and short of it is you're not going to be able to successfully communicate with your whole subnet. Same thing if it's too large, it's going to attempt to ARP for things that are not local. Where you see that come into play is a major factor is with VPNs. Maybe somebody on one side has their whole network set to like 10.something/16, and the other side has a 24 subnet inside of that /16. Well, the sides that are local to you, they're just going to ARP. They're not going to know that that is a remote subnet. They're never going to try to even send that traffic to the gateway. So, the mask is just too large and it needs to be reduced in scope. Aside from using your gateway and things you can use, but there are also static routes. But if you have a route that's incorrect, it can send traffic out a way you don't expect. And so anything not matched by ARP, in your subnet, by a static route, whatever, that remaining traffic will go by your default gateway. Something you might want to watch out for, because it's not very obvious, especially on Windows, that you could have a persistent static route configured on the client that may be pointing to something old. Now, in a new deployment, that's not usually a big factor, but if you're replacing some other bit of gear, say you're renumbering what your gateway should be, or you're retiring some old router, you're switching an old router to a VPN or vice versa, you might have a static route hanging out on a client that gets easily forgotten. So that's something to watch out for. Look at the routing table and on your clients and see what you see. Okay, well, let's start doing a little bit of troubleshooting here. When you do your WAN configuration, one of the first things to look for, and I'm kind of going WAN, LAN inside I picked it arbitrarily, but we'll sort of look at it from a perspective of maybe a port forward in this case. But there's also cases where you'd be looking at this either first in the port forward case or last in the client case. So you want to have your IP address configuration from your internet provider on hand, your WAN address, your subnet mask, what your gateway is, and also which IP addresses in your block, if you have one, that they have said are usable. We had something like this last week where an ISP said, okay, well, you've got this whole /27 here, but neglected to properly inform the customer that their routers were using the first 3 addresses in the block. And so the customer tried to use the IP address 1 up from the gateway, and couldn't get anywhere. No traffic was flowing. It turns out they had an IP conflict because the ISP gear was using like VRRP or HSRP, and it was occupying the first 3 addresses in the block. And so once they moved to a free address, everything started to work. So you might need to double check with, especially on larger blocks. It's not going to be a problem on like a /30 because they can't. It's rarely a problem on like a /20 on a /29 or something, but it's still worth checking with your ISP which blocks are usable. Sometimes they'll tell you. If they don't, make sure to confirm. Another thing to check for is the subnet mask is correct. Very common for that to be left on /32 or set to /1 accidentally. And a /1 subnet mask is going to make about half the internet be unreachable, which isn't not a very obvious thing. I'll go through a little demonstration of troubleshooting here in a bit, and you'll see how that one works. You need to ensure your correct gateway is used and that it's online or applies to ping. And if it doesn't respond to ping, you can check under diagnostics and ARP, make sure it shows up there. If it doesn't show online and it's actually up, you might have to set a different monitor IP address to something that does respond to ping. Something else that's come up on 2.3, our dpinger utility sends out monitor pings with a 0-byte payload, and some equipment doesn't like that. So sometimes you've got to set a payload size of at least 1 under the gateway entry. So go to like system and routing and edit the gateway and set a payload size on the ping up to 1. It's not very common that you need to do that. It's not, I won't say it's super rare because there's a decent amount of stuff out there that does. We've had maybe half a dozen, maybe at most a dozen people on the forum see that, but it's rare, but it happens. So something to consider. And something else to check is just go to Diagnostics and Routes and make sure your default gateway is present and shown. Just like on one of these here, let me see if I can pull this up. Just going to go to Diagnostics and Routes. And see, I've got my default gateway listed here, and it has, has an address, and that 192.168.198.151.100.1 is my gateway. You can see these route uses are counting up, so it is getting used. If I go to my ARP table, I can see it here as well. And there's you can see I've got my gateway in the ARP table. And on this one as well, I'm going to go to status and gateways. Oops. And there is, it's online. So all good stuff on this one. However, if I go over to this one, I think the gateways are online on this one as well. Yeah, there we are. See, the gateways are online there as well. So our next thing to look at is the LAN IP address, the LAN configuration. Or did I, hold on, there was one, yeah, that's fine. Check the firewall LAN IP is correct. Just to make sure that it's using the address, the correct address in the subnet. Again, like I mentioned earlier, it cannot be in the same subnet as WAN or any other directly connected interface. It cannot use the subnet ID or broadcast address of a subnet. So if you're using the /24, it means you cannot use .0 or .255 for your gateway IP address, because those are the null route and the broadcast address respectively. And it can't conflict with anything else currently in the LAN segment. So say you're switching from some other product to pfSense, if that other thing is still online using its IP address, you try to bring pfSense up in the same segment at the same address, they're going to conflict. And also, if you intended to bring it up on .1 and maybe you had it in a staging configuration as .254, you need to make sure you've got the right address swapped in there before you put it in place. And again, as on the WAN, check that the firewall LAN subnet mask is correct. You wouldn't want to have it too wide, like I mentioned. Maybe it could accidentally be set to /16 or /32. We see /32s, unfortunately, more common than you'd think. And that would prevent it from communicating with anything else in that segment except for itself. Another thing to check for NAT purposes is to make sure that it does not have a gateway selected under interfaces LAN, because that will cause the firewall to treat the LAN as a WAN type interface, and so it won't make outbound NAT rules for it. And by that same token, you need to make sure that your WANs do have a gateway set. I thought I mentioned that on the previous slide, maybe I didn't. So you need to make sure that the WANs do have a gateway selected and that the LANs do not have a gateway selected. And also on your LANs, you want to make sure you don't have something like block private networks checked on the LAN. So like say I go to my LAN here, and this is one I've got set up in a bad way because we're going to demo it later, but just check there's block private network addresses and loopback addresses. You want to make sure those are unchecked. You don't want those set at all, especially if your LAN's private. I suppose if you had a completely routed LAN using a subnet, public subnet from your ISP or BGP or whatever, then you wouldn't have to bother with that. You could put that on there, but for the vast majority of people, you do not want those set. Okay, on firewall rules, again, you check those under status and system logs on the firewall tab. You can look for block connections. If traffic is showing in that log and as blocked, and you think it should not be blocked, then only one of two things could be happening. It's either hitting another block rule that has logging set, or it is not matching a pass rule that you think it is. On 2.3, you can look at the hit counters under firewall and rules. like say on your LAN here, and you'll see some number of states and then some traffic that's on them. So you can kind of get an idea if a rule is being hit or not. So if you've got a rule that you think should be getting hit, but it shows 0, well, either there's something up with the ordering of it, or that traffic is not getting to the firewall the way you think it is. These rules are always going to be on the interfaces where the traffic enters. So if a rule is to govern LAN traffic trying to leave, it still goes on LAN. So, it could be that maybe you've got the rule in the wrong interface. There could be some parameter on the rule that is not set to the right value. There could be, it could be trying to match the wrong address, or it could have a source port set when it doesn't need one, that sort of thing. So for whatever reason, that rule is not matching when it should be. So you can also look at your state tables to see what kind of stuff is going on here. So there diagnostics and states. It's like just to see my connections here to the GUI, I can just look for 443. And there's me going to the GUI. So if you see something in the state table, that means that it did pass already. And so because it passed, it's in the state table. So if you see it in the state table, you know it hit a pass rule. Obviously, it may not have logged because most pass rules are not set to log. But you might, look at your state and make sure that it's showing it's coming from the right place, going to the right place, and that it's on the expected interface that you want to see. And if it's going through the firewall, look for the state that it enters with and the state that it leaves with. You want to check your protocols and your firewall rules to make sure the traffic you're trying to pass will actually pass. It's very common because the default for a new rule is TCP. So you can see the port fields, and so it's less confusing. But if you intend to pass all traffic or some other protocol, then you need to change that protocol to any. So say you make a new interface, you hit add to make a new rule, you don't change anything, you just hit save. You might have thought you made an any rule, but you just made a rule just to pass all TCP. And so you might be able to make a web connection out because your TCP might work, but you wouldn't be able to get DNS working. You would not be able to ping through that. So that's a situation where you might see some things working, but not everything. And in that case, usually browsing will fail because DNS fails, but if you're trying like a web server by IP address, it would succeed. Another common thing we see is on the LAN rules, make sure that your destination on those is set to any and not WAN net. A lot of people get confused and think WAN net means the internet, when no, it just means the local subnet on your WAN, so your WAN IP address and mask defining that subnet there. So it does not mean the internet, it actually just means your WAN network. You want to check your LAN rule gateways and make sure traffic's not being misdirected. So if you have policy routing active on your LAN, you want to make sure it's not sending traffic out through a WAN or a gateway group that's preferring something that is not configured properly, or maybe you didn't realize it was going that way. Policy routing might be overmatching something. You might expect something to go out WAN when it's really going out WAN too. So again, that's something you check the states, see where it's going, maybe run a packet capture, see how it's leaving, that sort of thing. And your hit counters will help you there too. Another thing is easy to overlook is rules on the floating tab, especially if you've got something like pfBlocker enabled. You might forget that there are rules there. You might not see them because you don't go to the floating tab very often, or interface groups if they were defined. So you might want to look at those, make sure there's not rules there that might be blocking or misdirecting your traffic that aren't obvious. And if you do have something like pfBlocker involved, and you are having trouble, it's a good idea to take that out of the loop. You might just disable pfBlocker, clear out its aliases and rules and things, and just make sure that it's not active, so it's not interfering. And if you get connectivity back, it's got to be something in those pfBlocker settings. So another thing to look for is outbound NAT. So if say your traffic is coming in from your local client, hitting your firewall, you see it in a packet capture coming in, and you see a state coming in, but you still can't get out. Well, if you look in the states, if NAT isn't happening, you'd see the traffic leaving your WAN with the private address source still intact. Or you might see a state leaving your WAN that just has the local source and public destination. And that's a good indication that NAT is not applying. So what you want to do there is, go to Firewall and NAT and check your Outbound NAT tab. I'll show you a case like this one here, I think is the one. Nope, maybe. Oh, I gotta go. Wrong machine for that one, because I broke it, so we can troubleshoot it. All right, so if you go to your Outbound NAT, you might see like down here in the automatic rules that there's nothing there. And you'll see in this case, I've got it broken in a specific way that I'll get back to in a minute. Because the gateways are set wrong. You'll see it's got, it has Outbound NAT on the wrong interface. So if you're set for, like, say, manual Outbound NAT in that case, and you had a NAT rule that would match other things, maybe you don't have a NAT rule matching that source going out that specific WAN. That's a common thing we see with multi-WAN scenarios, especially when CARP is involved or for HA. Somebody might have set up manual Outbound NAT rules that would take care of that traffic natting things to the CARP VIP out WAN 1. Then when they came to add WAN 2, they forgot to add NAT rules, a whole set of them outgoing out WAN 2. And then, there's no NAT going out that way, so they can't send traffic out from the LAN that way. And so it appears to be down for traffic when really it's just missing NAT. So in automatic Outbound NAT, it can handle multi-WAN as well. And you'll see that like on a system like this one, I think I've got set up for that. See, it's got a set of NAT rules, automatic out WAN and out WAN 2. This one's in hybrid mode, so it's also considering the mappings up here in the manual rules as well as the automatic rules. So it matches what's up here and then it falls through here. If you're in manual mode, it only considers your manual rules, so you don't get that benefit. And there's also, maybe you disabled NAT for some reason, and then you need to, if NAT was disabled because maybe you have to do NAT for public segments or something, or no NAT for public segments, you could go to manual then and then just make a rule for your private traffic. You may not be able to use automatic. So whatever you do, if your traffic's leaving, it's not getting NAT, odds are your NAT rules are not right. You got to match them right. And if you're on automatic, there's a couple of things you need to check. Like I said earlier, you need to make sure your interface's WAN has a gateway selected and your interface's LANs do not. So like external facing interfaces WANs, they need to have a gateway set because those are seen as exit WAN type interfaces by the automatic outbound NAT code. And the internal interfaces like your LAN, your DMZ, maybe like an MPLS type interface, those should not have a gateway set because they should be seen as internal interfaces for the NAT rules. Now, when it comes to something like that as well, you can still have a gateway defined for those under system routing, and you can have static routes pointing other traffic there. It's just not a gateway selected for the interface as a whole. That's the trigger under like on the interfaces menu. And when you are working with outbound NAT and testing, you need to make sure to clear the states between every test. So if you do change your rules, reset the states before you attempt your test again, or in the case of something like ping, you need to stop your ping for about 30 seconds or more, depending on what your firewall optimization is set to. So in most cases, you're just going to end up wanting to stop your ping, wait 30 seconds and go again, or just reset your whole state table under Diagnostics and States on the Reset States tab. Now at this point, after checking all of that stuff, the firewall should have good connectivity as far as basic IP level connectivity, but it may not have functioning DNS. So there's a couple things you can do to check that over and confirm it's working. The first is just a simple DNS lookup on the firewall itself. You can just go to Diagnostics and DNS, or DNS lookup, and then just try something simple like google.com. Oops, would help if I could type it right. And then it pulled back a result here. So if that did work, great. You apparently have good DNS. If it didn't, then you might need to check your DNS settings, which I'll talk about on the next slide. Diagnostic ping test. You can try a few hosts by name and IP address. So you go over here to Diagnostics and Ping. Now, if you just do like google.com here from your just default source address here, that's going to send it from your WAN, and the traffic's just going to go out. But another good test to try is to change this source address here to your LAN, because what that'll do, it will source it from the firewall using the LAN address, going out the WAN, and that will make sure your NAT is working. So if I do this here and immediately go and look at my states, and I filter on that, got to catch it quick, but maybe I didn't catch it. Now there's a lot of ICMP on there. But you'll see if you catch it quick enough where you run a constant ping or a ping with more while you check that, you might be able to catch it, and you'll see the NAT state happening. Next thing to do is just go to traceroute. It's very simple to use as well, and you can run this from the WAN, and then again from the LAN. Just try google.com and see where it gets you. Now this can take a while to return in the GUI. If you do it from the shell or from the console, it's going to return as soon as you see it. But looking at that there, you can see, okay, it's 10 hops from me to Google, and off it goes. So you can kind of get an idea about where you're going from there. And then you got diagnostic test port to do your TCP test. Again, we'll do google.com on port 80. And we'll just see if we can get out. And there it says port test successful. So if any of these things fail, you can go back over the items we covered in the previous slide and double check things and run more in-depth tests. So functioning DNS isn't really as fundamental to IP level connectivity as all these other settings. However, it's still very important, because without DNS, you're not going to be able to browse the internet, because you're going to be browsing by host names, and you can't turn those host names back into IP addresses, which you need to actually communicate with them. So broken DNS is going to cause you a lot of pain. So first thing you do, like I showed you, is to do a diagnostic DNS lookup test. And just see if that functions, and if it doesn't, there's a few things you might need to check. In some rare cases, your upstream firewall might be blocking DNS. Sometimes your ISP may want you to use their servers, and maybe you're trying to use ones that are off of them, or it could be a very strict network that again enforces you to use just a specific resolver, or maybe they block packets that are too large. So you need to be careful that you're not trying to work around something you have no control over. If you're using the DNS resolver, a couple other things to look for. That's the unbound daemon. If you have forwarding mode on, check your DNS servers under system in general. Make sure they are configured to good working servers. If you have a gateway set, make sure it's set to the right interface. For example, if you have 2 WANs, you want to make sure you got at least one going out each WAN. And if your forwarders do not support DNSSEC, you need to make sure to disable DNSSEC if you're in forwarding mode, because it will just cause your queries to fail. So if you have forwarding mode disabled, which is the default, you should have no trouble getting out, but your firewall will try to talk to the root DNS servers directly and other authoritative DNS servers directly. So what you need to do in that case is make sure that your upstream is not blocking your outbound DNS access in general. Again, if your gateway is filtering DNS or anything like that, you need to work with them to either relax that, or you may have to fall back to forwarding mode if you can't do that. With forwarding mode disabled, you should be just fine to have DNSSEC enabled if you want, but there might be some cases where you notice that you might have to disable it, but those are rare with forwarding mode disabled. And if you're using the old DNS forwarder, which is the DNS mask daemon, it's really just governed by the DNS servers under system in general, like I mentioned, for forwarding mode and the resolver. So just make sure, again, that they're set to good DNS servers and that the gateways are set properly. Now, all of that on the firewall could be fine and dandy, but you may have something messed up on your client. So you need to make sure your clients are using the correct IP addresses and subnet masks. If they are hard-coded, that's easy for a typo or something to lead somebody astray. Not a big problem when you have DHCP unless somehow the DHCP scope is misconfigured, but at least if pfSense is handling the DHCP, we try to make sure not to allow an invalid configuration. So you should be fine if you're using DHCP from pfSense, but if you're not, there's a potential that something may not line up right. Again, make sure your client gateway is set right. Make sure it's pointed to the firewall and not some other gateway, especially if you were migrating from one firewall to another. Or if it's a case where you have two gateways and it has to use the other gateway, then something on that computer is going to have to send that traffic specifically out through pfSense, whether that's a static route on the host, or you might need to mask the source of the traffic coming through pfSense with Outbound NAT on the LAN. There are ways around that, but it'd be a very unusual situation when you have to do that. But again, it's something that does exist. You just need to be on the lookout for it. Same thing with DNS. If it was set to go manual, make sure it's pointing to the firewall if you're using the DNS forwarder or resolver, or pointed directly to a DNS server, out on the internet somewhere, or maybe an internal Active Directory type DNS server. Make sure it's pointing to a DNS server that works and that you can get a valid DNS response back from it on the client. How you test DNS on your client is going to vary widely by OS. You could have to use NS lookup, or you might use host or dig or drill. There's a bunch of different tools out there. Every operating system has a different set. So you just need to find out what works for your operating system there to test your DNS. So obviously, if you're going to test from your client out, a good way to do that, again, testing each hop in between, make sure that the client can ping its own IP address, and then check that it can ping the IP address of the LAN IP address of the firewall, which would be its gateway in most cases, and then the WAN address of the firewall, just to make sure that it has connectivity through the firewall, and then the default gateway on WAN. So up to that point, you're just testing your basic connectivity locally. So just like I said, the LAN IP address there, if that fails, it could be the LAN address on the client, LAN address on the firewall, it could be your LAN rules that are blocking that. If you can't ping the WAN, again, it could be the client subnet mask or one of the subnet masks on the firewall interfaces. But if you can't ping your default gateway, that's the first hop where NAT is going to be a factor. So you got to check your outbound NAT, and also make sure your client IP address is not too wide. Maybe it might think your WAN gateway is a part of your local subnet if your client mask is way off. And then after that, ping a host on the internet by IP address. The easy one for that is just the Google public DNS ping 8.8.8.8. So if that fails, there's a lot more things in play. Check your LAN rules, your outbound NAT, subnet mask, the firewall, WAN IPs and masks, and the firewall gateway. So that's a pretty good IP level connectivity test out. And if that all works, then try ping a host by name like google.com. If that fails, then you got to work on your DNS. Check your client DNS settings, firewall DNS settings, so on and so forth. All right, so a couple of things that I briefly mentioned earlier, but that can prevent traffic. First up, the captive portal, like I mentioned. Not only would it prevent a LAN host from getting out, it also prevents other hosts, whether it's on a DMZ, a WAN, or a VPN, they can't get into it. So you can add your bypass to get around that. The IPsec tunnel being enabled and configured but not connected. If you misuse static port on outbound NAT and two clients try to use the same source port to the same destination, that'll fail. The most common thing you'll see for there is somebody who incorrectly set static port outbound for 5060 and their phones are using a static source of 5060. The first phone will work, the second no more, they won't work. Because the first one gets a state, the others will fail because they can't make a state. If you have a misconfigured or malfunctioning package like Squid, you may notice that you can ping, you can get DNS, you can do traceroute, but a request on the web doesn't work. Well, maybe Squid is enabled and trying to capture traffic, but broken in some way, and so that HTTP traffic is getting run through Squid. And you would see that in your state table. You'd see the traffic getting redirected to the Squid port locally if you're looking at the state table. So packet capture in that case would show it entering the LAN and then stopping. But if you look in the state table, you'd see the state table sending that to the Squid port locally. So let me do a little bit of a demo here. I broke two things in a pretty specific way. First up over here, this guy, right now, he can't get out anywhere. Can't get there. Can't get there. And he can't get DNS. So he's pretty broken right now. So first things first, I was thinking, okay, well, check the firewall rule or firewall logs. You know, there's nothing being blocked on the LAN here. Everything looks fine. But I kind of broke my own rule here because I'm not testing out. So first up, let's make sure I can reach my gateway. Okay, I can reach my gateway. And then the WAN address I just happen to know is 198.51.100.7. All right, I can ping my WAN address. And the gateway for that is .1, but oh, I can't get any further. So I can't get there. So let me look at my states here. I got 192.168.198.51.100.1. So I'm going to look at my state table. Maybe I can just filter on ICMP and see it. Let's look at my client address. Oh. All right, it shows it coming in. Oh. All right. Maybe that's not the client address I thought it was. 198.51. There we go. All right, here we go. See, look at our LAN. We looked at it here. We see, oh, my client was 11, not 14, sorry. See the ICMP coming in LAN, and we look at WAN. Yep, it's leaving, but there's no NAT happening. It's got the private IP source. We could confirm that. Let's see, now that we know the client address, we can do a packet capture on that. See what happens here. Copy. On the LAN, let's look for that host address. We'll start. Let it run for a couple of seconds. Now, because I'm reaching the GUI from this also, we'll see some GUI traffic in this capture. Maybe we won't. All right, so there it shows my ICMP echo request coming in, and that's on the LAN. Let's look on the WAN. Let's time it out, look at it there. And we see it leaving the WAN, and it's got source address intact of the local client. So it's definitely a NAT problem. So let's look at the outbound NAT. Go to Firewall NAT on the outbound tab. And lo and behold, we have our NAT groups here, but interface LAN, why would it do that? Well, it's because we need to check our LAN configuration. Look, there's a gateway set on LAN that shouldn't be there. While we're here, look at that. Subnet mask looks right. That all looks good. Apply that change. Let's check our outbound NAT rules again. And oh look, there's no rules. Curious. So hey, let's go look at our WAN. And our WAN has no gateway set. So let's select our WAN gateway. might have caught a glimpse of something else that looked a little fishy there, but we'll get back to that. All right, so let's check our NAT again. Now look at that, interface WAN with the source of all of our local networks. That looks much better. And hey, I can ping my gateway now. And can I ping 8888? I can. But I can't ping by name. And can I ping this other IP address? No, I can't. Now we'll notice here in our states, if I try to ping that, let's keep that going. Run a capture while we run that ping. And that's looking on the WAN for it. Now see, I'd expect to see a packet leaving, but instead it's on ARP request. Now remembering what I said earlier, it's only going to ARP for something it believes in its own subnet mask. And that IP address is way off, which Bing tells me I should be looking at my WAN subnet mask. And here it is set to /1, which that's not right at all. So let's change that to a /24. Now with /1, it's kind of a unique case because about half of the internet is going to be unreachable. Depending on your address, it may be addresses from 0 to 127.255.255.255 that you can't get to. If you're on the upper half, it might be 128.000 all the way to 255s. So you need to, if you see something weird, like you can get some places but not others, that's a great thing to check. And hey, look, it's already responding. All right, and can I ping by name now? And pinging by name works. And I can ping that one too. So everything on here appears to be fine. All right, so I've got a port forward one I want to show you as well. So we'll do a quick demo on that. This one is behind here. Let's make sure I'm actually logged in. All right, so on here, I've got a couple of port forwards just for a couple of ports like AD and SSH go into a system behind here. So this guy's outside. Let's just see if I can get there, and I can't. So easiest thing to check first is almost always going to be your states table. And so that was supposed to be for port 2222. So I can search for :2222, and you can see it came in. Let's see, and that was the outside address. So let's see if I can just do port 22 instead. There, we caught both states. All right, so you can see it came in the WAN, hit the NAT, was translated in the WAN, and then it actually exited the LAN, or appeared to anyway, but it has a SYN-SENT closed state, which that means that whatever side is on here with SYN-SENT, in this case here, it sent a TCP SYN packet to try to open the connection. And the closed means the other side did not respond at all. So you might see one that says like SYN-SENT established. Usually that means that it went partway in and died on the way back. But in this case, it appears to have gone out LAN. So we know this is going to 10.3.0.15 port 22. So let's jump right to a packet capture on the LAN protocol TCP. Got our host address, port 22. We'll do a high level of detail on this one. Let's try that connection again. All right. Now that should be enough. Let's stop this. All right, and what do we got here? Okay, we can see that the traffic did leave, and we see the SYN packet, the little S here. If it was an if you see an S and a dot, that's a SYN ACK, or just a dot would be an ACK. So it's got that packet did leave, and it appears to be going to the right place. So let's jump over here and look at our target system. So I need to make sure I've got the right interface here. So you're just EM0. So if I do a packet capture here, and I'm looking for let's see, this would be 198.51. There we go. We'll just do that. Host. Actually, why don't I just do port 22? There's a billion ways you could filter this. So I come over here and I hit that. But it didn't see it. It should have, but it didn't. Hello. Not sure why that freaked out my VM here. I wonder if turning on the packet capture did something to the VM there. There we go. Aha, it did see it, but I didn't use -n, so it couldn't. The reason it got hung up is because I was trying to do a reverse DNS resolution and that didn't work. Okay, so it did see the packet come in, everything is there. So we know it's arriving at this host, and well, in this case, silly me, I had turned on a local packet filter and the rules were wrong, and hey, I disable the packet filter and it comes through. Now, in reality, you wouldn't just want to disable your packet filter, you'd want to fix your rules, but that was just a basic example to show you what that would kind of look like. So, you know, I looked at the states, I saw it coming in, I saw it go out, did a packet capture, I watched it leave, but I never got a response. Well, in that case, the problem is always going to be on your client in 99.99 out of 1,000 cases, whatever. You know, you're rarely ever going to see a problem or a case when that is not the end client's fault in some way. So in this case, it was a firewall rule on the client. Fix that. Now we're all good. Now let's just, for grins, can I ping 8888 from here? And I can't. Can I do, let's see, if I can make a web connection out to that. I can get TCP out. I can't ping, but can I get DNS? No, that's curious. So maybe I'm going to go on its firewall and look at my LAN rule. Or actually, no, first let's look at my states. Or even before that, let's look at my firewall logs. Let's take this piece by piece here. Go all the way down, and hey, look, those things were blocked. And we hit this over here, and see, it was blocked by the default deny rule. Curiouser and curiouser. So we go to firewall and rules, look at my LAN, lo and behold, that rule is set for TCP. So let's set that to any protocol, save it, apply it, and then, hey, I've got DNS. And I can ping out. And I can see if I can do both at once. If I can type, and now I can get out. So there's just a few examples of things that can go wrong. Just a couple of quick little demos there. So if anybody's got any questions or anything else you might want me to see if I can rig up real quick, I can run through stuff or just kind of give you a glance around or give you some ideas. But if you have any questions, go ahead and type them in the chat. If you are going to type a question, you might want to just let me know you've got a question coming because I know it can take a while to type. So just type something, raise your hand basically, and then I'll know to wait on you. I think I see one from Steve Wheeler who said, Interesting that it allowed the WAN gateway to be on the LAN, but it didn't in that case, because on this, if we look, which I should be able to get to now, it was actually not the WAN gateway, it was a dummy LAN gateway that I had actually added that was just the LAN address. So the reason it let me select that on the LAN is because I had also incorrectly added this gateway that didn't need to be there. So really there was no reason for that to exist. I just added that so I could misconfigure it on purpose, because yes, we have seen people do that before. All right. So any questions at all? Anybody? All right, well, if there's no questions, I'll go ahead and wrap it up. It was a pretty interesting one to do. I'd hope to have some more time to do some fun little demos, but we're kind of running short out of time. But those give you a couple of good examples of what you can do. Just some piecemeal troubleshooting, from the source of the traffic on down. It's a good thing to refer back to if you ever have any trouble in the future, trying to do that. Once you get a little bit of practice with it, it becomes second nature, and you'll be able to spot these things from a mile away. So just follow a good methodology, keep those tools in your back pocket, and you shouldn't have any trouble from there on. Thank you everybody for attending, and we'll see you next month.